Okay, number 1 says subtract 11 from 8, which I did here. And then it says take that difference and multiply it by 2. So the difference between the first two were -3 times 2, that's -6. And then it says take it to the third power. So you should have gotten -216. Okay. Number 2 said name a natural number that is also a rational number. It could have been any whole number, really, that's positive. So number 2, it could have been any natural number. You could have said 45. And you could say 45 over 1, right? Is also a natural number that's a rational number. Or 41 over 1. Okay, number 3, it says give any negative, forgot what it says. It says give an example of an integer that is not a whole number. So remember, all whole numbers are positive, and it includes the number 0. So a -3 works, -100 works, -1,000,000 works, any of those, okay? Anything. Okay, number 4, it talks about brownies, and it says 5 ounces of unsweetened chocolate can be made into 14 brownies. So I'm going to first set this up as a fraction. 5 ounces for 14 brownies, okay? But then it says, how many ounces do you need for 30 brownies? So you're going to multiply this number by 30 over 1, okay? And the reason I put the 1 there is because I wanted to keep it in fraction form. So look at the 14 and the 30. Can I reduce that at all? Stephen, can I reduce that?
Absolutely not.
By what?
No, I said no.
Oh, yeah, you can.
You're almost there. I'll say absolutely not.
They're both even, so you can divide them both by 2, right?
All right.
So this will be a 7 on the bottom. This will be a 15. Okay, when you multiply that straight across, that is 75 over 7, or 75 ounces. Okay? And I think that's C on your page, right? All right. Number 5, it wants to know which property has happened at each step. So at this first step, right here at 7 parentheses x plus 9 plus 3x, to the next step, what happened there? Yep, it's the distributive property. Okay? And then what happened from that step to the next step? Yeah, it's commutative because 63 and 7x changed places. They moved. So it's commutative. Which one is it? Which commutative?
Of addition.
Yep, of addition, because we're dealing with addition. Okay? And then the next part, what changes from here to here? I'm sorry, I couldn't hear you. Yes, associative, because on this first one, 7x is associating with 63 by the parentheses. And then on the next one, the parentheses move and make 7x with 3x together. So this is associative of addition. Okay? What happens in the next one? This one's a little tricky. Yeah, it's actually a reverse distribution. We're factoring out the x, but that's the same property. It's just going backwards. Okay? So then adding the 7 and the 10 together, that's just 10x. It didn't even ask you on the page for that property. But what changes from in the last 2 steps? Yep. The 10x and the 63x are changing places. They're moving, so that's commutative of addition again. Okay, so on this one, first thing we need to do with PEMDAS is work the inside of the parentheses. And in order to do that, we got to get a common denominator. So I'm taking that 2 and multiplying it by the other denominator, which is 3. And I'm taking the 3 and multiplying it by 2. So that way we'll have a 6 on the bottom for both of them. And 3 times 1 is 3. 2 times 1 is 2. And I did the same thing over here. This is already in sixths, so. Once I have it there, I can actually add them. They have a common denominator, so this one's going to be 5/6 divided by 4/6. Okay, I have a division. What am I going to do with it? Yeah, I'm going to flip the second one, right? So it'll be 5/6 times 6 over 4. Can I reduce that before I multiply through? Yep. I can actually take that 6 and make them both 1s. So 5 times 1 is 5. 4 times 1 is 4. Okay. Number 7 says, give an example of a rational number that is not an integer. Well, you can give any fraction, negative or positive. You can give a repeating decimal, or you can give a terminating decimal. Any of those would work. Okay? Those are rational numbers that are not integers. Number 8, it gives you a list of things. It says 2, 3, 5, 7, ... What's special about them? Well, they're prime numbers. Nine, it says, give an example of a real number that is not a rational number. So pi would be an example. Square root of 2 is an example. Did anybody have anything else they put down? You could say square root of 3, square root of 10. Okay? 10. 9 minus 16 is the same thing as saying 9 plus a negative 16. Which is what? Negative 7. Okay. 11, it says, take this improper fraction and put it into a mixed fraction. So you need to do some long division here. You're going to take 41 divided by 3. So how many times does 3 go into 4? 1, right? 1 times 3. And we're going to subtract that. So 4 minus 3 is 1. I'm going to bring down the 1. 3 goes into 11 how many times? 3. 3 times 3 is 9. Subtract it, you get 2. And that's 2 remainder, right? I can't go any further. So I'm going to use the clockwise rule of going from 13 to 2 to 3. So it'll be 13 and 2 over 3. Do your answer on that. Now, somebody from first hour said they went backwards. They took the answers and put them all into improper fractions and found it that way. That is a great test-taking strategy. If you don't remember how to do it one way, go backwards from the answer. You can do that. It's a great thing to use on the ACTs or MCAs as well. Okay? All right, on this number 12, we have 2 scientific numbers that we need to actually divide. So the first thing you're going to do is take this circled area and divide that part. So 32 divided by 4 was 8. And then the exponents, you're going to take 4 minus 6. And that's how I got negative 2. Okay? But if you notice the answers on this, it's in decimal form. So if I have negative 2 on there, that means I'm going to have 2 zeros in front of the 8. And put a decimal between the first 2 zeros. Okay, so that should be A on that review. All right, for 13, which is down below here, we're going to use PEMDAS. So we got to do inside the parentheses first. So what's 3 minus 1? 2. So 2 to the third minus 2 times 2 to the third. So we did parentheses, now we got to do exponents. So 2 to the third is 8. That makes this 56 minus 16, or 40, for number 13. 14 is kind of a large fraction. A lot of multiplying having to go on here. Because we had to find a common denominator, I just took 25 times 23. 23 is a prime number, so there's not anything much I can do with it. So when I did that, I got 575 on the bottom. Then 9 times 23 is 207. And the way I think about 25 is how much money do you have when you have 8 quarters? It's $2, right? So I always think of 25 as a quarter. So that gave me 200 pretty easy. Okay. So 207 minus 200 is 7, and that's your answer for number 14. Number 15, what you need to do is break these down into their prime numbers again. So 25 goes into 125 5 times. This is 5 and 5. And then 45 was 9 and 5, or 3 and 3 and 5. So I'm going to rewrite this. 5 minus 6 square root of 5 times 5 times 5 minus 2 square root of 3 times 3 times 5. And what are my pairs that I can find here? In this first one, what do I have I can take out? I have a pair of 5s, and I have a pair of 3s. Okay? So this will be square root of 5 minus, and when I bring that out, I'm going to leave that 6 there, but I'm going to multiply that 5 times 6. Leave that 5, the 5 that didn't have a pair, on the inside. Minus 2 times 3 square root of 5. So this will be square root of 5 minus 30 square root of 5 minus 6 square root of 5. And if I put negative 30 plus a negative 6, that's negative 36 plus a 1. So that ends up being negative 35 square root of 5. Okay, so for number 16, what we're going to do is we're multiplying two scientific notations. You're just going to take the first one on both of these, the 9 and the 4. 9 times 4. And that's going to be times 10 to the 8 plus a negative 6. So it'll be 36 times 10 to the second. And if you notice that the multiple choice here, these are all in decimals. So we're going to change this by putting 2 zeros on the end of it. So it should be 3600. $17 is a PEMDAS question, and so we're going to multiply first. So this would be negative 7 plus 21. And then that would be, 14. 18, the question was, I think, 30 over 0. What is that? Anything over 0 is undefined. Okay, I'm going to scroll down a little. Okay, number 19, you have a repeating decimal, and it has how many digits? 2 digits. So that tells us a little bit how we're going to do that. First of all, we're going to set n equal to 0.83 repeating. Now, we're going to multiply both sides by 10 to the second because we had 2 digits. So 10 to the second times n equals 10 to the second times 0.83 repeating. What is 10 to the second?
100.
It's 100. So 100 times n is 100 n equals 100 times 0.83 repeating is 83.83 repeating. But now it wants, our algorithm, we're going to actually subtract this very first equation. Okay, so minus n and minus 0.83. Those 83 repeatings disappear. So we have 99n over here. And we have 83 right here. To find n, we're actually going to divide both sides by 99. So our final answer here is 83 divided by 99. If it was a 3-digit repeating number, what would have I multiplied both sides by? 1,000. Yep. Okay, 20 is different than 19 because it's a terminating decimal. So what we do to find a fraction is, first of all, we got to find the final place value here, which is in what place? Thousandths place, okay? So we're going to take 612, divide it by 1,000. And we need to reduce that number. Well, I know that 12, the last two digits, is divisible by 4, right? So I know that 4 goes into both of these. So I'm going to use the number 4 and do my long division here in case this is that part of the test in which you can't use your calculator. 4 goes into 6 once. I'm going to bring 6 minus 4 is 2. Bring down the 1. 4 goes into 21 5 times. 5 times 4 is 20. Subtract it, you get 1, and I'm going to bring down the 2. And 4 goes into 12 3 times. So my final answer on this is 153. And I know that 1,000 divided by 4 is 250. It'd be like taking $1 and splitting it 4 ways. You know it's going to be like a quarter. Okay? So that's your answer on that one. On the next part, it says a club has 30 male members and 25 female members. If the club is to have a contest where there are all male and all female teams competing, what is the most members a team can have? All teams must be equal size and everyone must be on a team. Okay? So what they're actually asking us for is the GCF, or greatest common factor. Okay? So what we're going to do is do a factor tree of both. 30. What goes into 30? 6 and 5, and then 2 and 3. The other one is 25, and that's just 5 and 5. So what do they have in common? 5. So the greatest common factor they have in this one is 5. But one of the things I wanted to ask you guys is, say the other one was 50 instead of 25. Okay? That would break down into 5 and 10, 2 and 5. Compare that to the 30. What do they have in common? A 2 and a 5, right, for both? So your greatest common factor in that would be 2 times 5, which is 10. Okay? So whatever they have in common, you're going to take one of each and multiply them. All right? For 22, it's just asking you if this is true or false. Does 7, parentheses, 50 plus 27 equals 50 times 7 plus 27 times 7? And yes, it is. It's a distributive property. Okay? 23. It wants to know if it's greater than or less than sign there. And that should be this. 24, it wants to know what, I'm trying to erase that. It wants to know what this number is, 10 divided by 11 in decimal form. Okay? So I'm going to take 10 divided by 11. But 11 does not go into 10 already. We know that. So I'm going to go ahead and put a decimal here and use 100 instead to start with. Okay? So 11 goes into 100 how many times? 9. 9 times 11 is 99. If I subtract that, I have 1 left over. I'll bring down this 0. Does 11 go into 10? No. So I have to put a 0 here because of that, before I can bring down another 0. 11 goes into 100 9 times. You guys see what's happening here? It's repeating. So the repeating decimal is 90. 25, we have 14 plus a negative 15, if I rewrote it, which is negative 1. So on this first one, on 26, we're doing some division again with scientific notation. So we're going to take those first numbers on there. 30 divided by 6 is 5. Okay, and then we'll subtract the exponents. So it'll be 5 minus 4. So it'll be 5 times 10 to the first, which is the same thing as saying 50. On 27, we are doing a division problem with fractions, so we need to make sure we're multiplying by the reciprocal. If you notice, look at the diagonal here. I can either reduce it first and then multiply straight across, or I can multiply first. So I'm going to multiply straight across first. 12 over 8. What can I reduce top and bottom by? 4, right? 4 goes into 12 3 times, and 8 divided by 4 is twice. That should be your answer on that one. 28 was a prime factorization number for 470. If you do your factor tree, you should have gotten 2 times 5 times 7. 29 you need to do a factor tree for. I'm going to do 30 times 10, 5 times 6, 2 and 3, 2 and 5. So if I rewrote this, it would be 2 times, I have 2 sets of 2's, I have a 3, and I have 2 5's. With the pair of 2's and a pair of 5's, I can take those out. So I'm going to write this as 2 times, and I'm going to put it in red. Because it's a pair of 2's, I'm going to put that there, a pair of 5's. And I will leave this one all by its lonesome inside because it had no partner. 2 times 2 times 5 is 20 square root of 3. I know, that's why I don't like that problem. So we'll go over it. Number 30, it gave you a formula and it says you're 78.4 meters from the ground. So you're going to replace your h with 78.4. And when you divide that, you end up with square root of 16, which is 4 seconds. And this is the type of problem I probably would have on the calculator portion of the test. But you can reduce it by dividing it first and then solving that. Okay? 31 is a rationalization problem, and in order to rationalize it, we're going to multiply the bottom and the top by square root of 18, so we can get rid of that square root bracket. So this would be 12 square roots of 18 over 18. What goes into both 12 and 18? 6 does, yeah. So 6 goes into 12 twice, and 6 goes into 18 3 times. But we're not done yet. What else do we have to do? Yeah, so we got to take that 18 and find the prime numbers in it. Okay, so let's do that right here. What goes into 18? 6 and 3 and 2 and 3, right? So 2 square root of 2 times 3 over 3. What can I take out? A pair of 3's. So it's going to be 2 times 3 square root of 2 over 3. Can I reduce this at all? I want to reduce it before I multiply through, just because I might as well. There's a 3 there and a 3 there. I can get rid of it. So it'd be 2 square root of 2. Okay? Number 32 is a stinky problem because they left the problem not completely simplified, which I don't like. Okay? So I'm going to solve this problem, and I'm going to go ahead and reduce it all the way. Don't worry about what the answers say there, because I'll tell you what the correct answer was in a minute, but we'll do it the way it should be, okay? So on this one, we have 2 and 3 as a denominator, and we have 100 on the top and 16 on the top. So there's two things you could do. You can either take the square root, go ahead and get rid of those square roots, or you can rationalize the find the common denominator. And before, as you can see from my numbers here, I did the denominators first. But this time, I think I will do the square root. So what's the square root of 100? 10, right? So this will be 10 over 2 plus 4 over 3. Okay? Common denominator, what am I going to multiply this one by? We're going to multiply by 3 and multiply this one by 2. Okay? So we'll have 30 over 6 plus 8 over 6, which happens to be 38 over 6. Can I reduce that? Yeah. It ends up being 19 over 3. That's what the answer should have been. Okay? The one they gave you, though, that would have been correct, was 19 square root of 4 over 6. That works, too. Okay? Okay, and now we finally come to our last page of our review. This is pretty quick. When you're multiplying common bases with exponents, you're adding the exponents. So this would be 9 to the third, and if you actually put that in the calculator, you get 729 out. On 34, whenever you have a negative exponent, that ends up going to the bottom, so it'll be 1 over 5 squared, which is 1 over 25. And then, I don't know why I wrote this backwards, but going down to 35, 8 to the second to the third. Notice it's an exponent of an exponent, so we're multiplying those. It'll be 8 to the sixth. Number 37 is to the negative 7, so I write all these digits down and put 7 zeros in front of it and make sure I have a decimal between my first two zeros. And this one, I know I'm going to put a decimal point here, so I need to count all the digits behind it, and there's 8 of them. Okay, so that ends our review.